Okay, so in this video I'm going to discuss about another important aspect in software testing, uh, which is called logical coverage, and we will discuss different aspects of logical coverage in this video. So logical expression basically can show up in many situations. For example, you can see logical expressions coming from sources like decisions in the program. You can also see these in finite state machines and state charts, which is a little bit more descriptive and formalized form of finite state machines. And you can also find these in software requirements. In that case, these will be in generally in informal form, but these can definitely be formalized, but that does not necessitate that the logical expressions will disappear. Generally, formalized requirements also have some sort of logical statements in them. So in the case of these logical statements or logical expressions, tests are intended to choose some subset of the total number of truth assignments to the expressions. So generally, logical expression can either be true or it can be false. So depending upon what sort of testing we want to do with these truth assignments, we will be interested in covering certain possibilities of truth combinations of these expressions. So the basic logical expression is called a predicate, and it can actually contain clauses, one or more. So what is a predicate? A predicate is an expression that evaluates to a Boolean value. So generally speaking, a predicate will always evaluate to true or a false. So a predicate can contain Boolean variables, and it can also contain non-Boolean variables, which will be connected by the relational operators, the less than, the greater than, the less than, equal to, greater than equal to, less than equal to, and not equal to. And it can also contain function calls. So the internal structure of the predicate is connected by the logical operators. So these you might be familiar from discrete mathematics. So the negation operator will invert any Boolean value. For example, it will convert a true to false and a false to true. The conjunction operator, which is also called the AND operator, it means when the two literals which it is connecting are both true, then the answer will be true, otherwise it will return you a false. And the disjunction operator, which is also called the OR operator, it will return you a true when both the operands are at least one of them is true, and if both are false, then it will return you a false. The implication operator, it has a truth table of the form. For example, if I have two operands for this operator, let's say the truth values can be false, one can be true, the other can be true, and both of them can be true. So the P implies Q column will have values true, true, false, and true, meaning that it will be false only in this case when the left hand side of the implication is true and the right hand side is false. So the left hand side is also called the premise, and the right hand side is also called the consequence. So the exclusive OR operator, when any one of the operands is true, then it will return a true. When both are either 1 or 0, then it will return a false. And the equivalence operator will return you a true when both are identical, like both operands are 0 or false, or when both are true, then the equivalence will return you a true, and when any one of them is true, then it will return you a false. So these logical operators can be present inside a predicate. So the next definition is of a class. A class is a predicate with no logical operators. Means these operators will not appear in a class, but these can definitely appear in a predicate. So some examples and facts. For example, you can consider this predicate. So it has 4 classes. So you can just mark these logical operators. This. So first part, second part, the third part, and the fourth part. So these are the classes in this predicate. The first one consists of 2 operands which are connected by a relational operator. So this forms a relational expression. The next one is a Boolean valued function. It will always return you a true or a false. So that is why it can be used as a connective for this operator OR. The next one, a capital D, basically represents a Boolean variable. And then there is another relational expression at the end which is connected by the greater than equal to operator between the operands m and n times o. So this is again a relational expression. So in this predicate we have seen 4 classes. And what do we mean by a class? A class will not contain any logical operator like and, or, not, implies, and equivalence or exclusive or. So generally it is a fact that the predicates we use in programs, computer programs, have very few classes. So this is based on a study of 63 open source programs, and it consisted of more than 400,000 predicates. And in this study it was found out that 88.5% of the predicates had just one class, 9.5% had 2 classes, and just 1.35% had the 3 classes, and only the remaining had like 4 or more classes. So it means if we develop criteria for up to 3 classes, that will be appropriate for testing these kinds of programs, and that will leave us with very few of these predicates which have more than 4 or more than 4 classes. So predicates can basically appear in the decision statements in the programs. They can be the guard statements in the finite state machine. They can also be present in the decision statements in UML activity graphs. They can also be present in the requirements, which can either be formal or informal, as I discussed on the previous slide. And you can also see these in structural query language queries. So in testing we use predicates as follows. First of all, we will develop a model of the software as 1 or more predicates, and then we require the test to satisfy some combination of the classes inside the predicates. For that we need to have this kind of notation. The capital P represents the set of predicates which we want to study in the model, which will be present in this model we developed first of all. Then the small p is a single predicate in this capital P. Then capital C is the set of classes in the set of predicates, and C subscript P is the set of classes in a single predicate P. The small c is a single class in class C, or set of classes in P. So this takes us to the simplest criteria in logic coverage. These are called the predicate coverage and the class coverage. Like we had some very simple criteria in structural coverage of graph, which consisted of the node coverage and the edge coverage. The first and simplest 2 criteria required that each predicate and each class be evaluated to both true and false. The first criteria is to evaluate a predicate in both forms. Since the predicate can both be true and it can be false, so we will cover both these possibilities by means of our coverage criteria. And the same can also be done for a class, because a clause is also either true or false when evaluated. So we can make use of these two criteria to perform the predicate coverage and the class coverage. So this is the definition of predicate coverage. For each P, means a single predicate in the set of predicates P, the test requirement contains two requirements. First, this single predicate evaluates to true, and second, the predicate evaluates to false. Means we need to find those set of values which will make the predicate in one case true, and in the second case the values will make the predicate false. So if we can successfully do this, we can say that we have achieved predicate coverage for that particular predicate. So when predicates come from conditions on edges, this is equivalent to edge coverage. So as we can see that generally the edges are formed because of some if statement in the program. It will have either a true branch or it will have a false branch. So that is based on this condition, which can be a predicate, and if it evaluates to true, then it goes to the true part, and if it evaluates to false, and then it goes to the false part. It means if the predicates are some sorts of condition on the edges, then achieving predicate coverage is equivalent to achieving edge coverage in the case of a structural coverage criteria on a control flow graph. So predicate coverage does not evaluate all the clauses. So it is not necessary that each clause gets a true or false value when we achieve predicate coverage. You can achieve predicate coverage by just maybe tweaking around with the values of some or maybe one clause and not changing the other clauses. And what is class coverage? This is denoted by CC. For each single clause in the set of clauses C, the test requirement contains two requirements. First is that C evaluates to true, and the second is C evaluates to false. First we were thinking in terms of the predicate, now we are talking about the clauses. So here we have an example. First we want to compute the predicate coverage on this simple predicate. It has this class, and this class. So for achieving predicate coverage, first we need to find a set of values that will make this true, and then a set of values that will make it false. So when we want to make the predicate true, you can have this set of values a equal to 5 and b equal to 10, means that this part will become true. We have d equal to true, means this will be true or true, and m equal to 1 and n equal to 1 and o equal to 1. When we put these values here, then this makes 1 greater than equal to 1. So that is also true. It means in this case the whole predicate will evaluate to true. So this is the whole computation in this part of the slide. And how we can make it false? We just need to make one part around the end, either on the right or on the left, to be false, and we will get the predicate to be false. Let's try that. So in this case you can see we just swap these values. We made a equal to 10 and b equal to 5, means this part will become false because 10 is not less than 5. We also made d equal to false. It means this whole expression on the left of the AND operator is now false, and the remaining values on the right hand side are the same, but that does not matter because false and true will give you false. So in this case the predicate will be false, and since we have provided a set of values that make the predicate true and that make the predicate false, therefore these are adequate to achieve the predicate coverage for this particular predicate. And what do we do in class coverage? In class coverage, we have to think about each class and we need to make it both true and false. For example, the first clause is a is less than b. Here you can see a is less than b. When we want to make it true, we have to choose such values that will make this class true. So if a is equal to 5 and b equal to 10, then that is definitely a true statement because 5 is less than 10. Therefore, this class will evaluate to true. And if I swap the values of a and b, then definitely that is not true because 10 is not less than 5. In that case, this first class will be evaluated to false. And in the same way, we can make this boolean variable d both true and false with a couple of statements. So in this case, d is true and d equal to false. It means we achieve the class coverage for this boolean variable d class by assigning values true and false. Now the last expression or last class is left, in which we have m variable on the left hand side of the greater or equal to operator and n times o on the right hand side of this operator. So if we choose these values m equal to 1, n equal to 1 and o equal to 1, so 1 is greater or equal to 1 times o, that is definitely true because 1 is equal to 1. And if we choose these values, which in the right box in the middle, 1 is greater or equal to 2 times o, that is definitely not true because 1 is less than 4. So these set of values will achieve the class coverage for the last class in the predicate. Now we have two sets of values. We can combine the first set of values in the true part, a is equal to 5, b equal to 10 from here, and d equal to 2 from here, and m equal to 1, n equal to 1 from here. So this can form or provide us the first test. And in the same way, we can combine the false part or the values which made the classes false. So the first class was made false by these two values. The second class was made false by this value, and the third class was made false by these values. So if we use these here, this forms our second test, and these two tests are enough to achieve class coverage for the classes in this particular predicate. So that is all for this video, in which we covered some basic notation for using in logic coverage, and we also discussed about two basic criteria of predicate coverage and class coverage, and we worked out an example which showed how we can choose different set of values for a predicate and classes that can achieve predicate coverage and class coverage respectively. Thank you.